Okay, guys, you have independent and dependent events, and it is here in your book, and that is lesson 7. Okay, independent and dependent events. Like any other lesson, you must know vocabulary, you must read correctly, you must solve correctly. You want to be successful, this must happen. You must read correctly, you must solve correctly. You must know vocabulary. Now, the vocabulary in this lesson is independent and dependent events. Okay? So, an event is when something occurs, yeah? An activity occurs. Something happens. So, we have two types of events, independent events and dependent events. Independent means you do by yourself. It doesn't matter what somebody else is doing, you must do by yourself. That means you don't need somebody else to happen, okay? That's what independent means. You happen whether there is somebody or there is no somebody. Now, what happens? Let's look at activities that happen by themselves. You come to school, whether Aisha comes to school. Let's say Miss Lillian. Miss Lillian will come to school regardless of whether any of you come to school. So Miss Lillian coming to school is independent, okay? It does not depend on how many students she has in the class, okay? Like the sun rising. The sun rising does not depend on anything. The sun will rise whether you are there or not. Tomorrow the sun will be there, okay? The sun going down in the evening, it will happen. Whether you are in UAE, you are in Saudi, you are in Qatar, it doesn't happen. It doesn't matter. The sun will go down whether you're here or not. It doesn't depend on you. Okay? When you toss two coins, each coin is different. It doesn't mean because I toss the first coin, I'll get ahead and I'll also get ahead on the second coin. It might happen, it might not happen. So the tossing of two coins is independent. The tossing of two cubes is independent. Okay? All right? Like getting a boy or girl. Yes. If the first child in your home is a boy, does that mean the second child will be a girl? It could be a boy. So the probability of getting a boy or a girl is independent of each other. They don't depend on each other. Okay? Spinning a spinner and rolling a cube. Yes, you spin a spinner over here, you roll a cube over here. Two different activities. They don't depend on each other. Okay? Now, the probability of two independent events can be found by multiplying the probability of the first event and the probability of the second event. So let's say we call the first event A and we call the second event B. So I am saying if A and B are independent, for me to find the probability of A and B, I have to find the probability of A, find the probability of B, and then multiply them. Now let us look at an example. So I am choosing vowels. So this is example 1 in your book. That's all I did. We are doing this example, example 1. The question says I need to choose a vowel from the tiles and a vowel from the spinner. So I wrote here. I have these ones are my letters tiles and this one is my spinner. And I want to choose a vowel. I need to know what vowels are. Vowels are letters A, I, E, O, U. Okay? Now, how many vowels are in the tiles? 2. How many vowels are in the spinner? 1. How many outcomes? I have 4 here, I have 3 here, I have 12 outcomes all together. You should remember counting principle. Yes, fundamental counting principle. Now, so I want the probability that both will be vowels. Both will be vowels means 2. That means I need to pick a vowel from a tile and I need to pick a vowel from a spinner. So the probability of picking a vowel from a tile and then probability of picking a vowel from a spinner, and I multiply. How many vowels are in tiles? There's 2 of them. How many vowels are in a spinner? There's only 1 vowel, A. Now, that means 2 vowels out of 4 tiles. and one vowel out of 3 tiles. So 2 out of 4 times 1 out of 3 is 2 out of 12. This 12 tells me I'm correct because I should have 12 outcomes. I simplify, I get 1 out of 6. I can write my number as a fraction, a decimal, or a percent. Let's do example 2. In example 2, they gave you a spinner. Sorry, they gave you a cube and a spinner. The number cube has 1 to 6. So you have 6 outcomes. And your spinner has 5 parts, or 6, 5. 1, 2, 3, 4, 5. So I wrote my sample space, and I know you have 5 outcomes. Now, how many outcomes do I have together? 6 times 5, I have 30 outcomes in all. What do I want? Not spinning a blue. You have to remember this, not. Probability of not getting a blue is 1 minus the probability of getting a blue. How many blues do I have? Only 1 blue. Out of how many? Out of 5. So what will I do? 1 minus 1 out of 5. I get 4 or 5. Probability of not getting a blue is 4 over 5. Then I want probability of getting a 3 or a 4. A 3 or a 4. So those are 2. 2 out of how many? 2 out of 6 numbers. I write it over there. Then now we need to solve my probability. The question said probability of not getting a blue and getting a 3 or 5. So that means probability of not getting a blue multiplied by the probability of getting 3 or 5. Probability of not getting a blue, we solved it over here. We found 4 over 5. I wrote it over there. Sorry. I wrote it over there. Probability of not getting a blue, 4 over 5. Probability of getting a 3 over 5, 3 or 4 is 2 out of 6. So I wrote it over here. Probability of 3 or 4 is 2 out of 6. What do I do with my 2 probabilities? I multiply them. Why? Because these 2 events are independent. So when I multiply them, 4 times 2 is 8, 5 times 6 is 30. I got 30 here. I confirm this 30 should match with this 30. If these 2 numbers are different, that means I did something wrong. Okay? Then I simplify. My common factor is 2. I get 4 out of 15. I can write my answer as a fraction, a decimal, or a percent. So we have done independent events. Now let's do dependent events. Dependent, 2 events are dependent. Then you must do the probability of both events occurring, means the probability of one event followed by the second event. That the second event cannot happen without the first event. So the second event depends on the first event. So if 2 events are dependent, then the probability of both events occurring is the product of event 1 and the probability of event 2 happening after event 1. So event 2 cannot happen if event 1 did not happen. If event 2 can happen without event 1, then that's independent. If event 2 depends on event 1, that means you need event 1, then you can do event 2, then those are dependent. Let's look at examples. You want to make tea, you must get milk. You cannot make tea without milk. So you get milk and then you make tea. So tea is dependent on the milk. Okay? You want to pass exams, you must pay attention in class. For you to pass exams, first of all, you must pay attention, then you can pass exams. If you don't pay attention, you will not pass exams. So passing exams depends on you paying attention. You must cross the road. Yes? So if you want to cross the road, first, you must check if the road is clear. If the road is not clear, you cannot cross. If the road is clear, then you can cross. So for you to cross the road must be clear. So that means there's no cars on the road or no vehicles on the road. So the event of you crossing the road depends on whether there is a car on the road or there is no car on the road. Okay? That's what dependent events happen. Now, you have two events. Let's call them A and B. And they are dependent. How will you do that? So the probability of A and B happening when A and B are dependent is the probability of A happening multiplied by the probability of B happening following A. Now let us look at an example. What does this mean? If you see it in an example, you will understand. You have a basket. In the basket, you have 4 oranges, 7 bananas, and 5 apples. How many fruits do you have? You have 16 fruits all together in one basket. You have 2 people who want to pick fruits from this basket. If 2 people want to pick fruits from this basket, so 2 people, we choose Latifa and Aisha. Aisha and Latifa. So who goes first? Aisha goes first. Aisha goes to the basket and picks a fruit. After Aisha picks a fruit, then Latifa can pick a fruit. Latifa cannot pick a fruit before Aisha picks a fruit. So that is why we said Aisha selects a piece of fruit at random, and then Latifa selects a second fruit at random. Find the probability that the 2 fruits chosen are apples. So that means you need 2 apples. So how many apples do you have? You have 5 apples. If you have 5 apples and you have 2 students, if Aisha picks an apple, it will be 5 out of the 16. Now, after Aisha picks the apples have reduced. They have become 4. And your total fruits have also reduced. They have become 15. So that is why for Latifa, we cannot use 16 and we cannot use 5. Because Aisha already took and Aisha reduced the 15. Aisha reduced the 16 and now they have become 15. So the probability for Latifa to choose is 4 out of 15. So that's why I wrote, when Aisha took, she did not put it back. So that means I remained with 4 apples. And if I have 4 apples in the basket and Aisha already took one of the fruits, I'm remaining with 15. So what will I do? For me to find the probability of 2 apples, I will do 15. 5 over 16 times 4 over 15. Which will give me 5 times 4 is 20. 16 times 15 is 240. And then I simplify. I get 112. I can change to decimal to percent. Okay? Let's do an example. What's the probability that an apple was chosen, a banana was chosen, and an orange was chosen? Okay? And this is dependent. So, an apple was chosen will be 5 over 16. A banana was chosen will be 7 over 15. An orange was chosen will be 4 over 14. Like that. And then you multiply. So, you do 16 times 15 times 14. You get 3,360. And then 5 times 7 times 4. 5 times 7 is 20. Times 4 is 140. Like that. And then you simplify. You divide by 10 first. You get 14 over 336. You divide by 2. You get 7 over 168. Let's confirm. 336 divided by 2. 168. And here is your answer as a fraction. So the probability of an apple being picked, a banana being picked after an apple, and an orange being picked after an apple is that. This is your steps and you get your work. All right, let's look at the last example. Maybe that was the last example. Example 3. Yes, that was the last example. So I've explained to you. So please do A, B, C, and then we will talk about them tomorrow. Okay? And do Aleph, Doc 1, 2, and 3.